Hello, thought I'd introduce you to my friend. So I've always wanted to have a picture with eyes that follow you, and what I've done here is created a picture that as you walk past, her eyes follow you and they can follow you left to right as you go along. Looking at the back side of the picture, you can see that I've got the Arduino at the bottom left there, and up at the top I've got a servo motor, and that servo motor is connected to a piece of card which moves left or right. So if I just activate the light sensor on this side here, you see that the servo motor moves to the side that the motor is on, and then waits for a little while, then moves back to the centre. And looking at the opposite sensor, if I just shine a light onto that one, you see that the servo motor moves in the opposite direction, which is then moving that piece of card either one way or the other, and hence moving the eyes to the left or to the right. So I just painted a picture on a piece of canvas and then cut the eyes out, which look quite strange, and then painted some eyes and put them on the back of cereal packet cardboard and attach them to this servo motor. So we'll look at the electronics in a bit more detail.
I got the idea from Billy Bass. For those of you that might remember Billy Bass, it's a singing fish. And when you walk past Billy Bass, he starts singing to you. Now, looking at a Billy Bass, I noticed that it was just using a light-dependent resistor as a motion sensor. So it got me thinking, how on earth can you use a light-dependent resistor, something that just changes its resistance to light, to detect motion? I'm using a light-dependent resistor, an LDR, that's the one in the circle on the left-hand side at the top, and balanced with a fixed resistor of about 1 kilo ohm. So the light-dependent resistor, LDR, changes its resistance depending on the light value it receives. If it's bright light, it's low resistance, and if it's in the dark, it's a high resistance. But the input to the Arduino is a voltage, not resistance. So I have to balance out the resistance with another resistor using in a configuration called a potential divider. So one leg of the resistor, of the fixed resistor, goes to ground. The other leg connects to the LDR, and the opposite leg of the LDR connects up to 5 volts. So now it means that that middle leg, which is now going to A1, changes its voltage. If the light dependent resistor has a high resistance, then the A1 voltage will be low, and if it's a low resistance on the LDR, then A1 will tend towards the 5 volts, and it varies between 0 and 5 volts.
So I've connected a light dependent resistor, or an LDR, that you can see here, to one of the analog ports of the Arduino, and I'll show you the circuit diagram in a moment. What I've done in software, just by way of showing you, is graphing the output of the light dependent resistor. So when I shine a bright light on it, you'll see that the value goes up, and then as the light goes away, the value goes down. So the output value is proportional to the amount of light that's being shone on it. So I wanted to make a motion sensor out of a light sensor, and what gave me the idea was seeing Billy Bass, or Billy Bass rather. So Billy Bass is a fish that sings when you walk past it, and I've had a look at Billy Bass and I noticed that it was just using a light sensor to see when people walk past it. But people don't shine, but what does happen is that when someone walks past a light sensor, it changes. Let's just rescale slightly, but they'll always cast a bit of a shadow inadvertently. There'll always be a slight change of light. So if there's a way of looking at the change of light rather than the absolute value of light itself, then you can trigger something. And in this case, you could trigger the eyes left, or with the sensor on the other side, the eyes right. So what I've got here is I've changed the program slightly, and what it's outputting is the change of light. So it's the difference of light. So as I move past the light, you can see that it just spikes up slightly. That's a bit clearer as the light changes. So what it does is it takes a reading, it waits for a certain amount of time, let's say half a second, and then takes another reading, and then takes the first reading and the current reading, and the difference between them divided by time is the light change per time. So you probably see it clearer if I shine a light onto it. So it's the change of light. And what that means is that it doesn't really matter what the ambient light is in the room as long as there's some light, but it's the change of light that as a person walks past, they will change the light falling on the light sensor in some way. So what we can do is look at that change and then trigger the eyes left or the eyes right, depending on the amount, well, depending on when the light value has changed or not. So I'll show you the program that allows it to do that.
So here's the program. So right LDR is right light dependent resistor. Actually, this is just a program to show you the change in light values. So it reads the sensor on port A1, and what I have here are a few more variables which I'll use a bit later on. Having a look in the main program loop, right is the analog sensor of the right light dependent resistor. And then I have a variable called diff_r. So it's a difference, which is the difference between the right value and the previous right value. So it's right minus that. And then the apps just make sure that it's always a positive value, because if this value is larger than this value, then it would be a negative. But we always want to work with a positive value. And then the previous right value is then made equal to the right value. Actually, I've done it twice here. So I've made previous right is previous right, and then previous right is the right value. It actually changes it twice over the loop, so it makes for a slightly bigger change. And then I show you that difference. So that difference is the right minus, well, it's actually previous right. And then the crucial bit here is that there's a delay. So what we're doing is reading a sensor. We're waiting for a specific amount of time. In this case, it's 60 milliseconds. And then we're reading the sensor again. And the difference between the first sensor reading and the second sensor reading over time is equal to the rate of change of that sensor value, or the velocity. So it's the velocity or the change of light value. So it's a way of getting a bit more information out of a simple sensor which can just detect brightness. You can do the same with a position sensor. So you might measure position of a wheel and then wait a certain amount of time, maybe a few milliseconds, and then measure the position of the wheel again. And then if you take that new position, subtract the previous position, then you've calculated the velocity of the wheel. So that difference will be greater the faster the wheel moves. In this case, the value of diff_r will be larger if the value changes, in other words, if the shadow changes quickly, or if you shine a light on it or turn the lights on or off, it creates a spike that way. And here's the main program, the full program. So I include a servo library to allow the servo motor to be connected. And what I've got is the left light dependent resistor on A0 and the right one on pin A1. And the system runs as a state machine. So there's 3 states: eyes left, eyes right, and eyes center. And they're states 2, 3, and 4. State 0 is the initial state when it's just at rest. So when it starts in the setup, I attach the servo. So the servo pin is on pin 9. and just going to the main program, so the main loop program, it reads the left light dependent resistor and looks at the difference between the left light dependent resistor and the previous left light dependent resistor value. And it does the same with the right light dependent resistor. And what it does is it looks at the difference of the left and the difference of the right and makes a decision. So if that's bigger than a threshold value, DF is something that I just had to tune to make sure it actually works. And I've just set that to be 10, as you can see up there. So if the left is bigger than this threshold, then the state is set to be eyes left. Otherwise, the state is set to be eyes right if the difference of the right one is bigger than that threshold. Or if loop C, now loop C is just a little variable that just keeps increasing every time it goes around the loop. If it's bigger than 50, then it makes the eyes go to the center, so it looks straight ahead. So I switch the state that says, well, if the state is eyes left, then it runs a function called eyes left, and it resets the loop counter. And then afterwards it sets the state back to be 0. If the state is eyes right, it runs an eyes right function, then resets the loop counter and the state back to 0. An eyes center, it then does the same, resets them and sets the state back to 0. And the end of the whole loop is a delay of 60 milliseconds. So let's have a look at one of these functions. So let's have a look at the eyes left function. So the eyes left function moves the servo to a particular position, which is 20. And the second value here is a delay. So I've created my own function which makes the servo motor move slowly. Now you can probably do this. There is a library which allows the servo motor to move slowly, but when I wrote this I didn't know that that library existed. So this is my little function that moves the servo. So let's have a look at this. So this is move servo to the position of the servo, and then D is a delay. So the larger that value of D, the slower the servo moves. And basically it goes through a loop that says, well, if the desired position is bigger than its current position, then count up, otherwise count down. And what it does is as it's counting, let's say it's counting up, then it moves the servo, it delays for a short, it moves the servo by a small amount, so it increases N from the current servo position, and it increases it one step at a time up to the final desired position. So it writes that position to the servo, and then there's a short delay, short period of time, and then it keeps looping until the servo gets to its value of pos. So that's counting upwards. Otherwise, it would count downwards. So I repeat all of this for the eyes left, the eyes right, and the eyes center. They just call this move servo command. So the eyes right, the only difference there is the position, 160. Eyes left is 20. So I found those values just by experimenting. And eyes center, well, I wanted them to snap to the center very quickly without any delay. So I just simply my servo right to a position of 90 degrees makes the servo move the eyes to the middle. So if I wanted them to move slower, I would change this second value here. So 20 is a nice slow value. Seems to work quite nicely. And that's the program.
Hope you enjoyed the show, and I'll try and paste the program into the comments section so you can just pick bits up out of it and use it however you like. But yeah, hope you enjoyed it, and good luck with building stuff, and hope you have as much fun as we do.